Now the first problem which I will solve is like this. So now please, this is very important. Until and unless we solve problems, we will not be capable to develop our ability to analyze problems. Now this problem tells that a steady state heat transfer in a tapered rod like this. There are some problems which I will not tell you the language or not show you the language. You can write in your own language. This problem is described like this. But for a big problem, I will show you the language. Now this is a tapered rod, the same thing which I did now. It is a straightforward application of a symmetrical tapered rod, where this x is this direction, this is x, where it is given the Q, the total Q which is coming here is 6000 watt. 6000 watt. Q is equal to 6000 watt. Now a steady state heat transfer. Now AX, here they are writing like that, A as a function of x. That means that any cross sectional area, this is AX, which is, this is AX, which is given by 1 minus x, where x is in meter and this is in meter square. How? We consider a unit depth of the tapered rod, that means depth L. If you consider L, that means this direction dimension L, then L is equal to 1 meter. So x in meter, so therefore this into 1. So this is the expression. The temperature distribution as measured experimentally is 300 into 1 minus 2x minus x cube. It is given in Kelvin. Kelvin, big K. X in meter and this is Kelvin, means 300, this constant is a dimensional constant. This will be Kelvin per meter. Oh no, Kelvin per meter cube, because 1 minus 2x minus 3x square. This is given Tx. Now we have to find out, what we have to find out? We have to find out the K, expression for K. This is the simplest problem to start with. That means this is a steady state equation. So which equation we will write? We will write d dx of K A x. A is a function of x into dt dx is equal to 0. That means K Ax dt dx is 0. But we are not interested in the temperature distribution. Temperature distribution is known. So we are not interested in this. So what we have to do to find out the K? We know the heat flux, steady state, heat, total heat transfer, not heat flux. I am sorry, here the heat flux will not be constant, because it will be times the area. The total heat transfer will be constant. That means Qx, we have to use this equation, is minus K Ax dt dx. We have to use this equation, Qx, because Qx is given. Qx is given. So we write this equation and find the value of K. So what we will do? We will write the values that given 6000 watt. That means 6000 is equal to minus K into A. A is what? 1 minus x into dt dx. That means 300 into 2 minus 3x square. 300 into 2 minus 3x square. dt dx minus kx minus 2, because this is minus 2 minus 3x minus 2x, correct? Sorry, that minus 2 minus 3x. So this is the simplest problem, and finally k comes out to be 20 by, because 6320 by 1 minus x into 2 plus 3x square. This is to start with, just warm up match like that. So warming up with this problem, that if a variable area is there, how can I take care of this area variation? That means our starting point, we have to remember that without thermal energy generation, this is the equation, not d square t dx square 0. Taking care of everything. If thermal conductivity constant, this comes here. So d dx of ax dt dx 0. But here temperature distribution is given already. I have to find out k, and I have to see what is given in the problem, total heat transfer, heat conduction, which is be same for all sections under steady state without heat generation. That means for any section, qx is minus kx dt dx, where qx is 6000, flowing through all sections. This clear? This is as simple as anything. Very primary school level things are like that.